In this lesson, we are going to do some 3D machining. The part you see can be opened by expanding the data panel and going into CAM Samples and then into the Tutorials folder. Select 3D Milling Toolpath Overview. Not only does this sample contain a variety of toolpath strategies, it shows them with different options activated. With so many different toolpath strategies available, it's common to wonder which is the best to use. If you can see how a toolpath is applied to a specific part shape, it can help you understand which strategy might work best for your part. It's about understanding the topology of your part and how these toolpaths might fit that topology. Don't be afraid to explore the toolpaths in this sample project. For this lesson, we will be working in the Overview 3D Practice setup. Make sure it is the active setup. This is evident by the dot shown at the end of the setup name. For this lesson, we assume you have been through the Introduction to 2D Machining. Many of the basics, like creating a setup, defining the stock size, and setting the origin work coordinate system, are covered in those lessons. You will also find many similarities on the Toolpath Strategy dialog. For the first part, let's go to the 3D Toolpath toolbar pull-down and select Parallel. Parallel creates a series of equal distance parallel cuts across the selected model. On the Tool tab, press Select to pick the cutting tool. If you click the document heading 3D Milling Toolpath Overview, the middle section will show only the tools for this project. Pick tool number 2, the 1/4-inch ball end mill, and press Select. For now, we will leave the default speeds and feeds for this tool. Let's go to the Geometry tab. This is where we can contain the toolpath in the X and Y axis cutting plane. As a default, Fusion 360 assumes you want to machine the entire part model. But we only want to do this one boss section. To do that, we will use a machining containment boundary. From the machining boundary pull-down, pick Selection. For the machining boundary selection, pick the lower edge that goes around the boss. Under the Tool Containment pull-down, you can select how to deal with that boundary. You can keep the tool inside the boundary, on center of the boundary, or allow it to move outside the boundary. All of these include an additional offset amount that can be a positive or negative distance. For this example, we will leave it set to Tool Center on Boundary and 0 for the offset value. Let's go to the Heights tab. Top height is set to Stock Top. Bottom height is set to Model Bottom. We will leave those as they are. Let's go to the Passes tab. Change the pass direction to 90 degrees and it will cut along the y-axis direction. Change the step over to 40 thousandths of an inch. With the direction parameter set to both ways, you will create a back and forth cutting motion. Press OK to create the toolpath. See how the toolpath along these steep walls seems further apart? It doesn't look that way from a top view, but it is a greater distance because of the angle of the wall. In the browser, right-click on the parallel toolpath and select Edit. On the Passes tab, enable Machine Steep Areas and press OK. Now you will see a finer cut along the steep wall. On the next section of the model, we have a boss that has near vertical walls. The contour toolpath strategy is commonly used to machine this type of shape. From the 3D Toolpath toolbar pull-down, select Contour. On the Tool tab, the 1/4-inch ball end mill should be shown. If it's not, press Select and pick the number 2 1/4-inch ball end mill. On the Geometry tab, from the Machining Boundary pull-down, pick Selection. For the machining boundary selection, pick the lower edge that goes around the boss. You need to consider the size of the boundary, the size of the fillet, and the size of the tool. A large diameter tool may not be able to stay inside or on center and still machine down the wall of the part. In that case, you might want an additional offset value. Our tool should fit, so we can leave the tool containment set to Tool Center on Boundary with an offset of 0. There's nothing to change on the Heights tab. Let's go to the Passes tab. Set the maximum step down to 40 thousandths of an inch. Press OK to generate the toolpath. You can see it did an excellent job on the walls. That is what Contour does best. But the toolpath on the top is not going to be the best. So we might want to limit the toolpath height in Z. Right-click on the Contour toolpath in the browser and select Edit. Go to the Heights tab. For the top height, the From pull-down, pick Selection and pick any vertex point on this top edge. Go to the Passes tab. We can also improve the number of passes on the shallow part of this fillet. Enable Machine Shallow Areas. This will add additional passes that roll over the top edge. There are minimum and maximum shallow values we can enter, but the defaults will be sufficient. Press OK to regenerate the toolpath. To machine the top of this boss, we can apply several different strategies. Let's try scallop first. This strategy will follow the boundary and produce cuts based on the scallop height. From the 3D Toolpath toolbar pull-down, select Scallop. On the Tool tab, the 250 ball end mill should be shown. If it's not, press Select and pick tool number 2, 1/4 inch ball end mill. On the Geometry tab, from the Machining Boundary pull-down, pick Selection. For the Machining Boundary selection, pick the top edge of the boss. I'm also going to add an additional offset of 60 thousandths to make sure it overlaps the previous toolpath. Go to the Passes tab. Set the step over to 40 thousandths of an inch. Set the inside-outside direction to outside to inside, and press OK to generate the toolpath. That creates a nice toolpath on the top that cuts from the outside of the boundary to the inside. We could have also used that on the entire part. It would have done a good job on the vertical walls. Next, I want to apply a parallel cut over the same area. But I don't want to reselect everything. In the browser, right-click on top of the scallop toolpath. From the list, select Create Derived Operation. From the flyout, select 3D Milling and then Parallel. This will open the Parallel dialog with the same tool, boundary, additional offset, and step over amounts. Press OK and it will generate a parallel toolpath in the same area. Let's do one more. In the browser, right-click on top of the Parallel toolpath. From the list, select Create Derived Operation. From the flyout, select 3D Milling and then Radial. This will open the Radial dialog with the same tool, boundary, and the additional offset. Radial creates a toolpath that resembles the spokes in a wheel. This toolpath requires us to specify the center of the wheel. Go to the Geometry tab, and for the Center Points parameter, select this point over the top. Go to the Passes tab. You will see this doesn't use a step over, it uses an angular step. Set it to 5 degrees. You can also control the start angle and end angles using the angular from and angular to parameters. Press OK and it will generate a radial toolpath in that same area. You can see this doesn't cover the top very well because the further it gets from the center, the wider the gaps will be. I'll show you another example where this works better. But first, here's something interesting. Select the scallop toolpath in the browser, and then look in the lower right corner of the graphics window. You will see the name of the operation and the machining time. Now select the parallel toolpath. Now select the radial toolpath. We can see the scallop and parallel toolpaths have a similar machining time. Let's move on to the cavity with the flower shape. In the browser, right-click over the radial toolpath and select Duplicate to make a copy. Right-click on the copy and select Edit. Go to the Geometry tab and clear the existing point by selecting the X next to it. Then select this point above the flower shape. Clear the machining boundary by selecting the X next to it. Then select these two boundaries on the outer rim of the cavity. Go to the Passes tab and change the angular step to 2 degrees. Press OK, and the new radial toolpath will be created between those two chains. Right-click over this radial toolpath and go to Create Derived Operation, then 3D Milling, and Morphed Spiral. The Morphed Spiral creates a transitioning toolpath between a group of curves. In this case, it will use the two curves from the radial toolpath to do a spiral blend between them. Go to the Passes tab and change the step over to 50 thousandths, and press OK to generate the morphed spiral toolpath. You can see we have a toolpath that transitions from the circle to the outer rectangular shape. Now let's duplicate that toolpath. Right-click over top of the duplicate and select Edit. Go to the Geometry tab. Click on the outer chain and select the garbage can to delete it. So we kept the circle chain. Now select each of the outer ovals. You should now have 6 chains. Set the additional offset to 0. Go to the Passes tab. Set the step over to 65 thousandths. Press OK to generate the morphed spiral toolpath. To see more examples of the morphed spiral, look at the toolpaths in the Cap Toolpaths setup. Let's make a duplicate of the parallel toolpath that we used for the top of this boss. Then we can drag it to the end of the toolpaths in our setup. Right-click over it and select Edit. On the Geometry tab, delete the machining boundary selection. Select the second cavity boundary at this position. Set the additional offset to 0. Press OK to machine the cavity. For our final toolpath, we are going to do a projection. Project lets you cut a 2D sketch onto a 3D surface. Go to the 3D toolpath pull-down and select Project. On the Tool tab, press Select to pick a new cutting tool. Pick tool number 6, the 1/16 ball end mill, and press Select. On the Geometry tab, under Curve Selections, pick the kidney-shaped sketch above the cavity. On the Passes tab, set the axial offset value to -20 thousandths of an inch for the depth of the cut. Press OK to generate the toolpath. You probably won't see the toolpath because it's been cut into the cavity. You can turn off the model visibility to see the cut. That's how you do a projection. Please review the other toolpaths in this file to learn more about what you can do. The last thing I want to show you is how to do a comparison of toolpaths. Let's expand the Overview 3D setup. Select the Contour All toolpath, then, holding the Control key or Command key on the Mac, select the other two contour toolpaths. Right-click over the top of them and select Compare and Edit. As you scroll through the page, you can see the parameters that are the same in green and the parameters that are different in orange. This is a great way to find out what made a toolpath work differently. You can even change the parameters in here. As an overview of 3D toolpaths, this lesson should give you a lot to get started with. Please experiment and enjoy.